Suppose we have 10 identical cookies and we want to distribute these cookies among 4 distinct children where some children may get no cookies. So for our problem, it's okay to not give cookies to one of the children. So in how many ways can we distribute the cookies? So what are all the possible ways of distributing the cookies? Okay, so let's think about this. So let x1, x2, x3, and x4 be the number of cookies received by each child, right? Received by each child. Okay, so child 1 gets x1 cookies, child 2 gets x2 cookies, child 3 gets x3 and x4. Now what do we know? We know that then x1 plus x2 plus x3 plus x4 is equal to 10. And we know that each one of the xi's have to be in between 0 and 10, right? So we don't need the, I mean, obviously if it's larger than 0, then they have to be less than 10, so we don't need to necessarily write that. But essentially, let's write it xi is larger or equal than 0 for I equal to 1, 2, 3, 4. And so this question about cookies can be reinterpreted as how many solutions are there to, or how many non-negative integer solutions are there to this equation here. x1 plus x2 plus x3 plus x4 equal to 10. And so let's see how we can solve a problem like this. So one way is through a technique, it's quite a general technique called stars and bars. And so how does stars and bars work? So the idea is that we represent each cookie by a star, and then we use bars to separate the groups for each child. So for example, let me give an example here. If we do 3 stars, and then a bar, and then 2 stars, and let's say a bar, and then another bar, and then let's say 5 stars, 2, 3, 4, 5. So this corresponds to x1, which is 3 cookies for child 1. This corresponds to 2 cookies for child 2. This corresponds to 0 cookies for child 3. And this corresponds to 5 cookies for child 4. And so notice that every such way that we sort of move around these stars and bars, every configuration of stars and bars is going to give us a different solution to the cookie problem, right? And every solution of the cookie problem can be represented in a unique way like this. So that means that counting the amount of solutions is counting the amount of configurations that we can do. And so in this case here, we have, so the amount of stars is going to be equal to the amount of cookies, which is 10. And then the amount of bars, so since we have 4 kids, we actually have 3 bars, because the bars are the things that go in between the separations here. So although we have 4 kids, there are like 3 in-betweens here, right? So the number of bars is equal to 3 here, which means that the total amount of symbols is 13. And so we must select, so we have 13 positions where we can put stars and bars, and we need to choose where to put, so here you could choose where to put the bars or where to put the stars. So let's say we choose where to put the the star. So we must select where to put, let's say, the 3 bars from 13 positions. So how many ways can we do that? So the answer to that will be we have 13 positions and we choose 3, and so this is the answer to our problem. It's 13 choose 3, and if you compute this, remember this is going to be 13 factorial divided by 3 factorial 10 factorial. So it'll be 13 times 12 times 11 times 10 factorial divided by 3 factorial 10 factorial, and these cancel out. And if you multiply this out, it'll give you 286, which means that the answer to our problem, so how many ways can we distribute the 10 cookies among 4 children, is going to be 13 choose 3, which is 286. So this is going to be a general theorem, or there's a general theorem for this, which we'll call stars and bars. And so it says that the number of ways to distribute n identical items into k distinct boxes. So again, the items here are the cookies, and the distinct boxes were the children. So each children is a box, I guess, for holding cookies, or you can imagine that each children had a box with cookies in their hand. When you allow for empty boxes, is going to be n plus k minus 1, choose k minus 1. Why? Because remember, you have n cookies, so these are the stars, and you have k minus 1 bars, so the total amount of symbols is n plus k minus 1, and you just need to choose where to put the bars, right? And so you have k minus 1 of them, and so it gives you that. And we saw that this equivalently, this counts the number of non-negative integer solutions to this equation.